Welcome everyone to my workshop. This is a workshop that I gave to the Mathematics Discord. It is a workshop about using LaTeX, so I'll talk about what that is. It's a mathematical typesetting sort of language that you can use to write up your homeworks or research papers. I am RAC, one of the users on the Math Discord, and I'm making a separate recording of this talk for anybody who wasn't able to make it. So let's start talking about LaTeX. So first of all, what is it? LaTeX is a document preparation and typesetting system. It's a system that's used by many different members of the math community and other STEM communities, from students to professors to various people working in industry. Pretty much anybody who's communicating about math, physics, computer science, and so on is using LaTeX. So important to note that it's pronounced LaTeX or LaTeX. It's not pronounced latex. So keep that in mind. And what is LaTeX used for? It's used for research papers. People use it to write up their homeworks and their problem sets for classes. You can even use LaTeX to write up your resume or your CV. I have my CV written in LaTeX and it looks really nice. And you can also use it for all kinds of other types of documents. For example, people make posters in LaTeX. You can make presentations in LaTeX. This presentation is just made in Google Slides, but if you've seen my previous talk on dynamical donuts, that presentation was made in LaTeX. So there are a whole lot of things that you can do with LaTeX, and it's a really, really useful skill to know. Why should you learn how to use it? Well, I think that it's sort of self-evident why LaTeX is helpful if you look at somebody's LaTeX files. They look really fancy and professional. If you've ever, sort of used the equation editor in Microsoft Word, you'll notice that your equations don't look nearly as good as the equations that come out of LaTeX. So it's just generally good for communicating mathematics. For students, your grader will be able to read your homework much better if you type it up in LaTeX than if you try to handwrite it and submit it that way. So this is a really nice benefit. LaTeX is great because it handles a lot of the formatting issues for you, so you don't need to spend your time stressing about where everything is placed. It handles a lot of that, and you can kind of just put things in place where they need to go. And another great thing about LaTeX is that it's really well maintained. There are a lot of packages and libraries out there that let you make any kind of mathematical drawing or diagram that you could ever want. So this is really, really useful for, if you have interest in doing crazy stuff like this commutative diagram was made using a LaTeX package, or this sort of representation of a neural network. These are all different things that you can do using all of the great libraries and commands that people have come up with that are freely available to you through the LaTeX community. And another great thing about LaTeX for our math Discord is that you can actually use LaTeX using the Texit bot in the Discord. So if you take the stuff that you learn in this workshop and just type it into the, into any channel in the Discord, it'll actually pop up with a LaTeX message. So if you want to test this out at some point, try using the LaTeX help or the LaTeX testing. Actually, probably the LaTeX testing channel is best for this. And if you have questions, you can ask in LaTeX help. So this is a really useful tool. Okay, so let's actually get started now that we kind of know what LaTeX is for. So there are a whole lot of different ways to write LaTeX. Many of them are offline. So for example, there are several IDEs or development environments where you can type out your LaTeX code and it will show the PDF right next to it. And these are offline editors that you can download. For example, TechMaker, TechShop, they're a lot like this. And some of them are great, but they are all a little bit clunky. So this is something to kind of keep in mind. Other people use their own offline editors that they like. For example, a lot of people use VS Code, which is what I use. I think it's really, really nice, but it's a little bit of work to set up. Some people also use things like Vim, which are much harder to use, but if they're used to using it, it might be more efficient for them. The third option is a really, really nice option that comes with a few downsides, but is mostly ideal, and it's called Overleaf. Overleaf is a website that acts a lot like Google Drive, actually. So you can make LaTeX projects which come with you on your account no matter what computer you're on, and you can also collaborate with people. So you can invite somebody to join your LaTeX project, and they'll be able to write in the same files as you and see the same output. So Overleaf is really, really useful. I highly recommend using it for the purposes of this workshop and while you're just getting started. Overleaf.com also has a ton of really great tutorials on how to use LaTeX, so after this workshop, you could use that to learn more. So one thing I'll suggest is that if you're following along and you want to actually actively do stuff in this workshop, that you head to overleaf.com right now and make an account. If you have an institutional email, so a .edu address, then you should use that because you'll probably get the professional version, which comes with some nice version tracking and things like that. And once you've done this, you're going to go to the main page and you're going to click New Project and Blank Project. Okay? And a new project is going to pop up with some stuff in it. So I'm going to do this right now. And you'll see over here, here's my sort of window with all my LaTeX stuff. And I can click New Project and Blank Project. And then I'm going to call this LaTeX Workshop. And I'm going to create the file. So you can see what comes up. There is 3 parts of the screen. On the left-hand side here, it shows main.tech. So .tech is the file extension for LaTeX files, which contain this sort of code in the middle here. And the stuff that's on the right is the PDF that gets generated when you compile this .tech file. So this .tech file is generating this PDF on the right. Okay, I'm going to hide this left window for now, just so that things are easier to see, because I've kind of zoomed in so that you all can see the text. But you can leave that window open, and you'll see different files in your project. So if you want to make new files, you can do that on the top here. And let's talk about what's going on here on these 2 parts of the screen. So on the left here, we have this code, and you might, take a look at this and recognize some stuff, some English words in this, but for the most part, it looks like computer code. I promise that our LaTeX documents won't look as much like computer code when we're actually writing them. This is all just the kind of preliminary stuff that Overleaf puts in to set everything up for us. Okay. And on the right here, we have this PDF that's been generated. So for example, we can see that the title of our file is LaTeX Workshop, and that's corresponding over here to this title at the top of the page. Okay. And in order to sort of get stuff from the left here over to the right here, we have this button right here, Recompile, or you can hit Control-Enter. Either way it works. And essentially what we're going to do is we're going to write stuff on the left here, and then it'll show up on the right when we hit Control-Enter. Okay? So let's talk about some of the stuff that we can do in Overleaf with LaTeX. So the very first thing that we can do is really basic. We're just going to write some text in. And the idea is that anything that goes between these begin document and end document lines will show up on the screen as text. Okay? So, maybe it won't show up immediately if we want to make math symbols, but what we can do is we can type words. So, for example, if we look at after the section introduction line, we can start typing. So I could say, this is my first sentence in LaTeX. And when I hit Control-Enter or when I recompile, it shows up. Now here's something that's interesting to notice. Even if you do enters, enters don't matter, neither do spaces. So I just did a lot of spaces there. Maybe I'll put it on the same line. There we go. So let's see what happened. See, all this stuff ended up on the same line, and there was no long space. But something that you can do is you can start a new paragraph by doing a double enter. Double enter starts a new paragraph. Another thing you can do is you can go to a new line without a new paragraph by using a double backslash. Double backslash starts a new line. So what does that look like? The paragraph is indented, but the backslash line, the new line, is not. Okay? So this is how you type text in. You can do lots and lots of stuff with this already, but we're using LaTeX so that we can type math. So let's start actually doing that. So how do we write math in LaTeX? All you need to do is you surround your equation with the appropriate characters. Okay? So for nicely formatted equations, which go in their own line centered, you'll use double dollar $signs like this. So double dollar $signs, then you'll write your math, and then another double dollar $sign pair. On the other hand, if you want math to show up in the middle of the line, so inline math, then you can just use single dollar signs, okay? And we can try this out with two examples. So for the centered math, we could say the equation for a circle is, and then I'm going to put in double dollar signs, x squared plus y squared equals 1. And let's see what pops up. So the equation for a circle is x squared plus y squared equals 1, which looks nice. And then we could also do the equation x squared plus y squared equals r squared defines a circle of radius r. And let's see what shows up here. Look at that. Now it's inline. So it didn't go to its own line. A few things to note here. One thing to note is that some people will tell you that you shouldn't use double dollar signs for these centered equations. There is actually another thing you can do. You can use a backslash and then a square bracket, and it'll do the exact same thing. So if I do this, I still get the same thing. Backslash and square bracket, and then backslash and end square bracket. Looks like it acts exactly the same as double dollar sign, but it's a little bit different in some subtle ways, and so some people prefer to use it. So it's something to keep in mind. If you're ever reading somebody else's LaTeX code, you might notice this, or you might decide to use it yourself. Okay. For inline equations, the single dollar signs are always okay. Okay. So even with this, we can start to type in a lot of math, but the reality is that most math symbols don't have keys on our keyboard. So many math symbols require special commands. So let's talk about some of these commands. All right, in LaTeX, commands are always going to start with a backslash, all right? And a backslash tells LaTeX, well, whatever comes after the backslash, you're going to write a symbol that corresponds to that, okay? So to make a math symbol, usually you're just going to use the command backslash and then whatever the symbol's name is, but sometimes things get iffy. LaTeX doesn't always use the symbol's name, and you'll have to pick up over time what different symbols are and what they should mean. But lots of them are really easy to remember. So for example, we could try some of the following. Remember that they should go in math mode because they're math symbols. So they have to go between the double dollar signs or the single dollar signs. So for example, you could use backslash lim, which is the symbol for limits. Sum is for a big sigma. Int is for an integral. For Greek letters, you'll do either lowercase, you'll do the lowercase name of the letter if you want the lowercase letter, and if you want the uppercase letter, you'll capitalize the first letter. So this is for a lowercase pi, and this is for an uppercase psi. Okay. There's infd for infinity. 2 is for if you have a function, f from a to b. 2 is that arrow between a and b. You could use capital R right arrow if you want to do implication. Then there's set symbols like in, which is saying x is an element of a, x is an a. Subset, ec, which has the little line underneath. There's the empty set, and then we have, for example, greater than or equal to, less than or equal to, and not equal to, given by gek, lek, and nek. So there are a whole lot of different symbols that you can use, and using some of these symbols, we can do plenty of stuff. So for example, we could say x is gek y, so x is greater than y, and we could say y is an element of b, and b is a subset ec of c. So let's see what shows up. So look at that. We've already got some professional looking math written down. So this is nice. Now the reality is that you're not always going to know which symbol to use at every point. So there's a really, really useful tool here for this that we can use. It's called Detectify. Detectify is a website that you can just search by searching Detectify in Google. And what it does is you can draw any symbol that you like, and it'll show you the LaTeX command for it, if it can figure out what your symbol is. So for example, I could, I might be wondering, how do I write a tensor product in LaTeX? So what I could do is I could draw my little tensor product symbol, which is a circle with an x through it. And look at that, it comes up with O times. So, maybe it thought I meant to type this Venus symbol, but it still shows you pretty accurately the symbol that you wanted. So I know that the tensor product is given by backslash O times. So let's try this out. The tensor product of, I should say like S and T is SO times T. And look at that, I was able to figure out what to type in using Detectify. So Detectify is a really useful resource. Okay, so now we know how to do a whole bunch of commands, and we can find new commands using Detectify, which is great. But we still don't know how to do a bunch of key things. So for example, we might want to do subscripts and superscripts. So before we actually used an exponent, we said x to the power of 2 and y to the power of 2. And we'll use this sort of thing again to do any sort of subscript or superscript. So to make a subscript or a superscript, you'll just use either an underscore or a caret, okay? So what you would expect for powers and what you'd expect for sub. Okay. So for example, we can already make some pretty complicated looking expressions using subscripts and superscripts. So I could define f1 from A to B by f1 of n is equal, and I'm actually going to put this in equation mode, f1n equals the integral from 0 to 1 of, let's say, x to the n dx. And what does this look like? So f1 from A to B is defined by f1 of n. It's equal to the integral from 0 up to 1 of x to the n dx. So notice that I did subscript and superscript on the integral, and it made them into the bounds of the integral. And I could have done it in the other order too. I could have done superscript and then subscript, and nothing changes. Okay? So this is how you make all of these subscripts and superscripts. Now, one important thing to notice is, for example, what if we want to type, what if I want x to the power of 217? So what's going to come up if I compile this? Well, it comes up as x squared times 17, which is not what we wanted. So how do I fix this? Well, what I do is I group the characters. So how do I group the characters? I just use curly braces. So in LaTeX, curly braces are kind of like parentheses. They tell you that things go together. So for example, now when I recompile this, look at that. X to the 217 is formatted correctly. The 17 is now up in the exponent with the 2. Okay? So this is what these braces do. And they are able to group things in both superscripts and subscripts, and they'll also group things in other commands. So this is really useful. So we can already do something kind of interesting with this. Let's type the Gaussian integral. And what is the Gaussian integral? The Gaussian integral says that the integral from minus infinity to infinity, and I'm going to put that in its own little group, even though it's only a single command. I don't need to, but it's just nice to sometimes. Of e to the minus x squared dx equals the square root of pi. So let's look. Look at that. That looks really nice. So two things to note here. This minus infinity right here, this needed to be in a group because it was two symbols together. But infinity on its own doesn't need to be in a group. So I can actually remove these curly braces, and it'll still work, okay? Because it's only a single command. Another thing to note here is that I had this group here which contained another exponent. And what LaTeX does is it kind of makes that second exponent a little smaller than the first one, okay? So this is something that you can do. And then the last thing to note is that I use the square root command. So the square root command is very similar to the subscript or superscript. It gives you this pair of curly braces, and you put in whatever you want under it. So, this is something that you can do. So let's talk a little bit more about these nice new commands that we have. So we just saw the square root command. We have lots of other nice commands, for example, fractions, overline, which is to put a bar over something, mathbf, which lets you change the font style. So we have all these different commands like this, And the way that they work is you put expressions inside of each curly brace pair. So for example, for square root, we put a pi, a backslash pi, inside of the two curly braces, okay? So for example, if you wanted the complex conjugate of a complex number, you would have backslash overline, and then you might write in the middle here, a plus bi, okay? So these are different things you can do. How does fraction work? Well, fraction has two spots, okay? And the first spot, you put in whatever you want the numerator to be, and in the second spot, you put in whatever you want the denominator to be. So we'll see an example of this. There are a few other useful commands that you'll use a whole lot. For example, the sine command, cosine, mod, there's log, there's plus minus given by PM. So these are all useful commands. In order to use the sine and cosine commands, remember that you need the backslash. If you forget the backslash, then you'll just see sin in italics. So I'm going to write this down. Let's see, sine theta versus sine theta. So what's the difference? Look at that. Sine theta does not look right. Sine theta looks much better. Okay, so remember that you need that backslash in front of your sine or cosine or log or anything like that. Okay. So let's try using these commands in a more complicated statement. For example, we can type in the half angle identity for sine. So the half angle identity. And if you are following along in Overleaf, you should follow along with this especially. It's a really nice thing to try typing out. So we'll take the sine of frac theta over 2. So notice here how I said the fraction with theta in the numerator and 2 in the denominator. So that sine is equal to plus or minus the square root of what? It's the fraction of 1 minus cosine theta over 2. And this is fine. But look, Overleaf is giving us a bunch of ret everywhere. So what's going on here? Well, we can see there's a little red X, and it says right here, unclosed group, open curly brace. Okay, so what that means is that I'm missing a closed curly brace. I haven't closed off one of the open curly braces. So let's find where that's happening. Well, this open curly brace pairs with this one, and Overleaf will kind of highlight very lightly the ones that pair up. So this is paired up. This one I don't see a pair for. So this says square root. Oh, and that makes sense because we opened the fraction, we did the denominator, but we didn't close off the square root. And look at that, it's solved. So now let's try compiling. And we have the half angle identity. So sine of theta over 2 equals the square root, or plus or minus the square root of 1 minus cosine theta over 2. Now, you might not like having the sine of theta over 2 in a fraction, so your other option is, of course, just to do division like this. So that's totally fine. You can just use a forward slash, and maybe you also prefer to have parentheses around the cosine theta. All this stuff totally works. So it all works fine. Yeah, so you can format things in lots of different ways, but the question is going to come down to more, how do you format it in a way which is nice and readable for whoever is looking at your work. Okay. So now we've actually done quite a bit with LaTeX, so we can already sort of type out whatever we want to type out and download our file and deliver it wherever we need to. So in order to download a file from Overleaf, you're going to press the little download PDF button right here on the top of the PDF. So there's this little download PDF button next to recompile, and it'll download that PDF to your computer, and you can then upload it to whoever you want to see that file. So for example, you could send it to your professor if that's how they want their homework submitted, or you can share it with people if it's a paper and you want them to see it. It's just like any other PDF file, and anybody should be able to read it. Okay? So the really useful thing about this is that nobody else that you're sending your file to needs to have your code in order to compile it. So I would very much recommend against downloading this .tex file and then sending that to people. Because sure, they'll have everything they need to generate your file, but they'll have to go and recompile it themselves. And this is especially bad if your file uses packages and things like that, because they might not have the packages that you used. So do not send people .tex files unless you're directly collaborating with them and they need to type code as well. Send them a PDF. Okay? Send them a PDF of the output. All right. So by now we've gone through a lot of the basics of Overleaf and of LaTeX, so you can do a whole lot at this point. Right now I'm going to share with you a couple of other resources that are useful and good to know about. After this, I'm going to talk a little bit more in depth about some of the formatting and things that you can do there, but at this point you know all the basics and you can kind of go off. So let me talk through a couple of these resources, and then we'll move on to some more advanced formatting stuff. So, for example, we already talked about Detectify, where you can find symbols by drawing them. There's also MathPix, which is a useful software that takes pictures of whatever you want. You can upload pictures, and it'll convert them into LaTeX. There's MathQuill, which turns your typing into LaTeX, so this is also useful. There's the Text Stack Exchange. So the Text Stack Exchange is kind of like Stack Overflow, which is where you can go if you have questions or things that you need answered about your LaTeX code. If you have like a question about how do I type this, or how do I make this command work, or why can't I find this symbol, usually if you search up your question in Google, it'll give you a Text Stack Exchange link, and you'll be able to find the answer really quickly, which is awesome. Just note that the Text Stack Exchange has a lot of very smart people with some sort of strange opinions. So, you might ask a question, or you might find somebody else has asked a question, and the answer will be something like, no, just don't do that, like, you shouldn't be doing this at all, blah, 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 blah. And don't get discouraged by this. People mean the best there, but they oftentimes will have, like, very kind of, extreme opinions about what you should be doing and not doing with LaTeX. And sometimes taking that advice is actually really helpful, because sometimes it'll save you from some bug or something that you wouldn't have known about. For example, I mentioned earlier the whole double dollar signs versus backslash square bracket thing. That's something that I read on Text Stack Exchange. So this is a useful resource. And then there's also this really cool fun little game called technique.xyz. So this is this fun little game right here, and what you can do is you can test out your LaTeX skills. So I'll just do one of these quickly. Oh god, it's a long one. So for example, here I would type m sub r, x1, x2, and I remember to do dots, I use backslash dots, xn, and what does that equal to? Well, I have to do cases, and I'm going to end it. Okay. And then in the first case, what's the situation? It's 1 over n, sum from I equals 1 to n of xi to the r, right, and then to the 1 over r. And that happens when r is not equal to 0. And the other case, we have the square root, but it's the nth root. So I do that of the product from I equals 1 to n xi. And that happens when r equals 0. So look, I got it. And now it gives me e equals mc squared, which would have been much easier. So you can keep going with this, and it's a fun little game. And it tells you all these different identities and things like that, and inequalities that you might not have known about or you might recognize. So this is a great little resource for practicing and for testing out your LaTeX skills. There's some other super useful packages that are available. I mentioned at the beginning that there's a lot of support for LaTeX. So here are some of the examples of packages that you can use. So there's AMS Math, AMS Sim, etc. These AMS packages are useful because they include a lot of extra important commands that you'll need. We'll talk about this in a little bit. There's GraphicX, which you can use to put images in your file. There's Texit, which you can use to make the cool diagrams that we saw at the beginning of the talk. So how do you actually use these packages? Well, right here, you might see this use package line at the top of our file that Overleaf automatically puts in. So I can just put in another one, and I can put in, say, AMS Math, and this is an extra package that's now in my file. So this is how you do that. It's very, very easy, especially in Overleaf. If you're using an offline editor, LaTeX might need to install the packages for you, okay? And it'll try to do that automatically most times, so that should be okay. Okay, so let's talk a little bit now about some extra stuff. So the first topic that I want to talk about is delimiters. So we've used some parentheses and some square brackets. They work just fine in math mode. You don't need to do special commands for them. But what about curly braces? So to do curly braces, for example, if we want to type in a set identity, so you might want to type in the set of all z such that z to the k equals 1. And you'll put curly braces in because that's how we type in sets. I should just type the set. But look what happens when you compile, those curly braces go away. So how do we make them show up? We just use a backslash in front of the curly braces. And look at that, they're there now. So the backslash basically says the curly braces here shouldn't denote a group of characters. They should denote actual curly braces. So this is sort of like a command for writing curly braces in. Okay? So this is one thing that you can do. Okay, and then another sort of thing to note is that delimiters can act kind of weird with big expressions. So you can use these left and right commands with delimiters and they'll resize. So for example, what if I type, I'm going to put this on in math or in equation mode, 3, what am I typing? 3 times, and then I put 1 plus fraction 5 over 2. And what happens? Well, look what happens. 3 times, and the parentheses are small. They don't cover up the fraction, which looks kind of weird. So we can fix this by actually taking those parentheses and putting a left in front of the left parentheses and a right command in front of the right parentheses. And watch what happens. The parentheses will resize to fit whatever's inside of them. So this is really useful, and it works for all kinds of other delimiters. So for example, square brackets work fine. If you want to do curly braces, as usual, you'll need to do this command. So you'll do a backslash left, backslash curly brace, backslash right, backslash curly brace, and it works fine. And you can do other stuff too. For example, absolute value bars. If you want to do the floor function, then you need to use the lfloor and the rfloor commands, and so on. Okay? So this is another thing that you can do. This is how delimiters work. Now we can talk about lists. So lists are a really useful sort of formatting tool. They kind of allow you to make these bulleted lists or these numbered lists that you can use for organizing things in your homework, or saying, item problem 1, problem 2, problem 3, and so on. Okay, so the important thing to note is that these commands do not go in math mode. They just exist outside of math mode. They don't go inside the $$ signs or single dollar signs because they're not math, they're just formatting. So in order to make a bulleted list, you're going to use this itemize environment, and to make a numbered list, you'll use this enumerate environment. And how do we actually start it? So we would say this is my list. So I'm going to say begin, and I'm going to put an itemize environment, and then I'm going to end with an itemize. Okay, I'm going to end my itemize environment, and inside I can put items. And then on each item, after each item, I can put whatever I want. So typing the first item, items can include math mode. So I'm going to write e to the I pi equals -1. And then this item is the third. And I get a list. So right here I have a list of things. It's bulleted. If I wanted to make a numbered list, I would just do an enumerate. So now it's 1, 2, 3, and I could say on the third item it has a sublist, and then I could add another enumerate. And inside this list, I'll have 2 items, subitem 1, subitem 2, and then I'll have one more item. This is the last item. So this item goes outside of the sublist, and you can see that I get a nice list like this. And LaTeX even puts A and B here instead of 1, 2, 3, 4 for the sublist. Okay, so this is all really useful stuff in order to make lists and organize your files. There's another way to organize things in your files, to use sections. So you might remember that at the very top of our code here, we started with a section introduction line. So we can make our own sections too. And we can even do subsections and sub-subsections and so on. So for example, let's add a new section. Let's say this is homework. And in the homework section, I could add 2 subsections. Problem 1, the answer is 3. And I could add another subsection, problem 2. I couldn't figure out this problem. And what happens? So we get 2 new sections, we get section 2 here, and we get 2 subsections out of it, problem 1 and problem 2. Now you might not want these sections to be numbered. If you just want them to be headers, then you can just add, after the section or the subsection, you can add a little asterisk. And that'll stop them from being numbered, and they'll just look like headers. So that might be preferable to you if you want to number the problems on your own. Okay, so sections are great, they're really useful. Now let's talk about the last topic. So the last topic here is the preamble, and we'll add some stuff to the preamble, okay? So what is the preamble? The preamble is all the stuff that was in our file originally that came before the begin document line. So stuff that becomes before begin document doesn't appear in our file, well, unless it's like denoting the title or something like that with one of these commands, but that's coming up because we have this make title command here. This stuff is part of the preamble, and the preamble always includes one really, really important line, this document class line. What does document class do? It tells LaTeX how to format our file. So I mentioned at the beginning that you could use LaTeX to make resumes, CVs, posters, slides, and so on. Right now we just have an article, which is just a simple text file. But you can also use LaTeX for all kinds of other things, like books, slides, letter. These are all different document classes that make your document look different. So you can try changing this to different document classes and see which one fits your needs. Okay. The next set of lines that we have here are these use package lines, which I talked a little bit about. So we included the AMS math package. Let's also include the AMS sim package. And you can add your packages here. You probably want to add them before anything else in your code, but it has to come after the document class line. That should be first. Okay. Okay, and now that we've added some packages, we can already do some interesting stuff. So for example, what do we do with the AMS sim package? It gives us Blackboard letters, for example. So let's try math BBR. And I could also do the complex numbers or the rationals. These are math BBC, math BBQ. So BB stands for Blackboard. It's a type of font, and it comes with the AMS sim package. So there we go. I've got R, I've got C and Q. So this is great. I've got lots of new symbols, but the problem with this is that they're sort of cumbersome to type out. So say you're doing your real analysis homework and you need to type the real number as a whole lot, then it's really useful to be able to make our own nickname for the command mathbbr, so that we could just do \r or something like that. And what we can do is something called a macro. So in order to set up a macro, we'll use the new command in the preamble. So what does the new command look like? What we'll do is we'll go up to the preamble and we're going to add after our packages, new command. And the first argument in the first pair of curly braces is going to be what we want the nickname to be. And the second argument is going to be what we want it to do. So we want the \r command to do math BBR. Okay, so I've added that. And now down here, now all I need to do is type \r. And let's see what happens. It works. So this is great. One thing to note is that the new command is only going to let you make a new command like this if this command isn't already used. Okay? So if you need to override another command because maybe you don't like what it does and you want it to do something different, then you're just going to need to switch new command to renew command. Okay, so let's try making a renew command, and we're going to replace the fee command with this weird sum. So I'll do sum from n equals 1 to infinity of frac 1 over n squared. How about that? And now what happens when we type in \phi? So \phi is now not the Greek letter. Okay. So it came up with that sum, and the sum kind of looks bad in display mode, or sorry, in inline mode, but if we put it in equation mode, then it looks nice. Okay. And what would happen if we removed that renew command and just made it new command? Well, LaTeX would give us an error. So you can see right here, this log and output file says error, command fee already defined. So we do need renew command if we ever want to do a new command. And you'll notice that here, it just came up with the normal Greek letter fee. So this is all stuff that you can do. You should be careful when you're defining new macros, especially if you're using renew command, because you'll end up with a kind of confusing, messy code. But even if you're just adding new commands, it can still get tricky. So for example, take a look at what my preamble looks like. It's something crazy like this with all these crazy new commands. Some of them are really simple. For example, I just use \i if I want infinity, which is a nice shorthand. But some of them are really complicated. For example, I use \dd with some arguments and things like that if I want to do partial derivatives. So the moral of the story is I'm lazy, and anybody who has to read my LaTeX code is in for a bad time. So you should, if your code is just for yourself or you're just writing up your homework and stuff, use as many macros as you want. But if you're working with somebody, you probably want to use less of them, as few as possible, and make sure that everybody knows what the different commands are so that you don't override something that somebody else has been using. Okay? So this is about it. Thank you very much for listening to my workshop. And I guess this is the recording, so there's no separate recording that will be available. But if you join the Math Discord, if you're not there, then you can find a link to these slides in the events channel. And thank you very much for listening to this workshop. I hope that you were able to follow along and get something out of it. And of course, if you need extra help, just visit the LaTeX help channel in the Math Discord. You can also check out the great tutorials on Overleaf. And there are plenty of different great resources out there as well for getting started with more and more advanced LaTeX. But hopefully this is enough to get you jump started. Thank you very much.